Alright, let us look at a numerical which is related to time and work in the quadratic equation chapter. A takes 6 days less than the time taken by B to finish a piece of work. If both A and B together can finish it in 4 days, find the time taken by B alone to finish the work. Okay, before we solve this question, there is a concept one needs to keep in mind, and that is, let's say A can finish the job in X days. And I'm not talking about the question here, it's in general. So A is a person who can finish a particular piece of work, which could be building a wall or painting a wall, whatever the work is. Let's say A finishes the entire job in X days. Then in one day, A would have done 1 by xth part of the job. Okay, so when we're writing it mathematically, we don't use this th and part, we just write 1 by x, and x is a number. So in 2 days, A would have done 2 by x part of the job. In the same way, x days later, A should have finished the job, which means x upon x, which is 1. This 1 actually represents the completion of the job. So whenever you want to represent the completion of the job, we will write it as 1. The remaining are all fractions of the job that has been completed. Now let's read this question. Says A takes 6 days less than time taken by B to finish a piece of work. So the time taken by A is dependent on the time taken by B. If B takes X days to finish the job, A will take 6 days less, that is X minus 6. So let's begin our question by assuming let B finish the work in X days, which implies A must finish, or A finishes the work in X minus 6 days. And that is because the question says A takes 6 days less than B. Now we will find out how much each does in one day. So in one day, B completes 1 by X part of the job, and A completes in one day 1 by X minus 6th part of the job. Now in the numerical it is said A and B together, they are finishing it in 4 days. So let's find out in one day how much of work is done when both work together. So in one day, A plus B together complete, it would be the sum of this plus this. So therefore 1 by X plus 1 upon X minus 6th part of the job. And what if they work for 4 days? In 4 days, A plus B would complete 4 times this amount, that is 1 by X plus 1 by X minus 6, and that should be the complete job, which is represented by 1. Now all we need to do is solve this. It will give us a quadratic. So what I'm going to be doing is I'm going to send this 4 to the other side, to the denominator. I'll take LCM here, which would be X times X minus 6. So this would be X times X minus 6. X minus 6 plus X is equal to 1 upon 4. So the numerator here becomes 2x minus 6, and I'm multiplying it with 4, cross multiplying here, which is equal to, this becomes x square minus 6x. So this is x square minus 6x. When you open the brackets, you would get 8x minus 24 is equal to x square minus 6x, and the quadratic that comes out of this is x square minus 14x plus 24 is equal to 0. Now if you observe the quadratic here, the middle term is minus 14x and the product is 24. So if we factor this as 12 times 2, 12 plus 2 will give us 14, and then 12 times 2 will give us 24. So putting the signs correctly, we should get minus 12x minus 2x plus 24 is equal to 0, which implies taking x common, x minus 12 minus 2 into x minus 12 is equal to 0. So x minus 2 is one factor, x minus 12 is the other factor, which is equal to 0, which basically means for x minus 2 equals 0 implies x is 2, x minus 12 equals 0 implies x is 12. Now if you investigate both these values, you would notice that x equals to 2 does not satisfy the condition, because remember we have taken b's time of completion as x. So if x were 2 days, which means b finishes in 2 days, it would mean that a finishes in 2 minus 6, that is negative 4 days, which doesn't make sense. Time cannot be negative, right? So we have to neglect this value. So we write neglect since time for a becomes negative. All right, so therefore the answer is 12. So we report the answer as B takes 12 days to finish the work. And that is the final answer.